Hello everyone. Let us now discuss LeetCode question number 2 in biweekly contest 148. So minimum cost to make arrays identical. We are given with two arrays ARR, BRR. Now we need to do only two operations any number of times, split array into any number of continuous subarrays and rearrange these subarrays in any order, and choose any element in array and add or subtract a positive integer x to it. This cost of this operation is x, but the cost of this operations is k, where I am rearranging this and return the minimum cost to make ARR and BRR equal. So let me take the example given in the question. So the first thing which I want to do is check whether this uh, makes a minimum cost in the same positions without splitting or rearranging them. So choose any element in ARR and add or subtract positive integer x to it. The cost of this operation is x. So if I take uh, this element and to make it 7 minus 7 plus x should give me 7. So the cost of this operation will be 14, right? So instead, what I have to do, instead of making this formula, what I might do is BRR of I minus ARR of I will give me the value of x. That's it, right? It is BRR of I and it is ARR of I. So it will give me the value of x. So let me take those values in the first thing. Now the value when I subtract ARR of I from BRR of I will get 14 here. That's it. The value of x is 14 here. Now minus 2 minus 9 will give me 11, and the cost here is the value of x is 11. Now minus 5 will give me 10, right? Here I am adding minus 11. So minus 2 minus 9 is equal to minus 11, right? It is the value of x. Minus 5 minus 10 will give me the value of minus 10. Now the thing is, choose any element in ARR and add or subtract a positive integer x to it. The cost of this operation is x, but here we are taking the negative value. So what I have to do here is I need to take like only positive arrays. So this is not the way I can do it. I can't get the negative values because when I get these negative values, it is exceeding the value of 14, right? 14 minus 21 will give me like 7, sorry, yeah, 7 minus 7, which is the cost is going to negative. So I cannot do like this. I cannot go to negative. So instead of making this, what I meant to do is I will split this array. But how can I split this array? That means here they gave split array into any number of continuous subarrays and rearrange this and add or subtract a positive integer x to it. The cost of this operation is x. Now instead I can do like here I have 9, which is the nearer element to 9 in BRR. It is 7. Now because why I am choosing the nearer element, here it is 7 and here it is 9. So if I add, or if I add only 2 to 5, now if I add only 2, then I will get 2 7. That's it. So I need to get the nearer element. for every element in ARR. So that's why I have got these uh, elements in integers, right? Here it is 0. Now minus 7, 5 and 9. Minus 7, 5 and 9. These are elements in ARR. Now instead of splitting this, I am taking the element in this format. Now what I might do here is, in this array, minus 5 comes first, minus 2 comes next, and then 7. Minus 5 and then minus 2 and then 7. Right. Now, what is the absolute difference between these two? It is 2. And next element is minus 2 and the next element is 5. And what is the absolute difference? Instead you can also count like the distance between them. It is 7. Now we are having 7 and 9. What is the absolute difference between it? 2. Now 2 plus 7 plus 2 will give me 11. But what am I missing here? It is the value of k, because we rearranged them. First we got minus 7 and then 9 and then 5, but we placed the 5 in the sorted order. So we need to add the value of k, as they gave value of k as 2. Now if I add 2 to 11, then I will get 13 as my answer. That's it. It is as simple as that. But wait, what if I got the original cost which I got by just removing or just subtracting ARR of I from BRR of I is less. So that's why I also have to maintain the original cost and also get the cost by splitting this. So I need to get two costs and return the minimum one. But how can I do this? So to do this, we need to have the original cost initially, and n is the size, and then we need to have a multiset, because a a will be stored all the set all the elements in the vector of ARR, and B also stores all the elements of BRR. After that, we need to iterate this multisets, because we will be having this, this in a sorted manner in this multiset A. So, iterator A will be iterating through A multiset, and itb will be iterating through B multiset. Now, after that, the cost which is after I got by sorting is stored in sorted cost, and I will be iterating through this array, two arrays ARR and BRR. Now, the original cost will be incremented by BRR of I minus ARR of I. Now, after that, the sorted cost will be incremented by absolute difference. So here too, I need to take the absolute difference, as I can go to negative here. Here I can get minus 11, as I said before. Here I can get minus 11. Here I can get minus 10. So instead, I will be changing it to 10, and here I will be changing it to 11, and here I will be changing it to 14, and here after all this I'll get the cost as 35. But here I only got 13. That's why I will return 13. So that's why take the absolute difference of iterator B, iterator B, the element iterator B minus iterator A. So after this iteration of ARR and BRR, return the minimum of original cost and sorted cost. Original cost and sorted cost. That's it. This is as simple as that. Now let me code this for you. First thing, have initialized the original cost. Let me take this. First thing, long original cost is initialized to 0 and int n is equal to array dot size. After that, as I said, multiset is used to store the elements in ARR and to the end, and then B will store the elements in BRR from the start to the end. Now, after the assigning multisets iterator A and iterator B. So for that, I'll be using auto iterator A is equal to A dot begin, and iterator B is used for B dot begin. Now, the cost after sorting these two is sorted cost is equal to 0 for int I is equal to 0, I is less than n, I plus plus, and iterator A is also incremented and iterator B is also incremented simultaneously. Original cost will be incremented by absolute difference of BRR of I minus ARR of I. Then here the sorted cost will be incremented by the absolute difference of iterator B, the element at iterator B, minus the element at iterator A. Now we need to return the minimum of original cost and sorted cost. I think it will be running. Let me wait. So sorry, I have uh, forgotten to add k. As I said here, add k. So k should be added here. Sorted cost should be added with k. As I said, k should be added to the sorted cost as we are splitting, and it will be cost by k. Now let me submit this. So if you like this video, share to your friends and subscribe to my channel. You'll be getting the solutions of contests and also POTD of LeetCode. And if you also want the POTD of GFG, you can contact me. I will give you the LinkedIn profile in the description. So thank you.